Okay, so let's talk about setting up proportions. We have solved proportions that have already been set up, but now we're going to talk about reading a word problem and determining how to set up a proportion, and it's actually really simple. I suggest getting out a highlighter so you can highlight some of these important words. You could also use your pencil to underline if you need to. First of all, to set up a proportion, what you need to find. That's the first question you're asking yourself. What do I need to find? We need to read the problem carefully to identify what piece of information is missing. This will be represented by a variable in your proportion. Now, a variable is a letter that represents the missing quantity. And a lot of times we'll see the variable is x, like this. But sometimes we can use different letters or different variables to represent what we're missing. For example, if we were wanting to know how many miles something was, we might use the cursive letter M to represent miles. Also, as you get older, the variables are normally written in cursive to just show you that it is a variable. Okay, number 2, what do you already know? We need to read the problem again carefully to identify what pieces of information we have. Amounts and units are important. It is very important because we will be talking about different things, comparing different things, and we need to be able to answer the question with its proper label. Next, we're going to write a proportion. We're going to set up a proportion keeping the units in the same place on both ratios. So the units have to be in the same place for both ratios. And we're going to talk about this as we do a few examples. Then we cross multiply and solve. Cross multiply and solve. And at the very end, you cross multiply again to check. But this is after you put your answer back in for your variable. Put your answer back into the problem, or we'll say the proportion. All right, let's go ahead and do a couple. Let's read the directions first of all. Practice setting up, not solving a proportion for each situation below. We are only going to set up the proportion. We are not going to solve it. Let's go ahead and read number 1. Kim earned $420 for 30 hours of work last week. That is our first comparison. So that's our first ratio. I'm going to put 420 over 30. So $420 to 30 hours. And over here to the side, I'm going to just make myself a little key so I can remember. I put the money on top and the hours on the bottom. And that's going to help me keep my units in the same place. Go ahead and put my equal sign for my proportion. If she earns the same hourly rate next week, how much will she earn? So that's asking us how much money she's going to earn, because we do not know, for 40 hours of work. So the other number we have is this 40 hours. And because I've made my key, I know that hours go on the bottom. So I'm going to put my 40 here. If you notice, it says how much. Well, much is talking about the money. How much will she earn? And I do not know, so I need to put a variable there. And I'm going to just use the variable x this time. And we are not solving the proportion. We're just setting it up. And this is how you would set up this proportion. Let's move on to the next proportion, or next problem. Ben traveled 1,800 miles over 3 days. So I am comparing miles to days. And that's the way I'm going to write my ratios. My first ratio is going to be 1,800 miles to 3 days. Now I'm going to keep reading. If he continues to travel at the same rate, how many miles will he have traveled after 8.5 days? Okay, so that says 8.5 days. I look over here and days is at the bottom. 8.5, and it's wanting to know how many miles. And for this variable, I'm going to put the letter M to represent miles, and that would be our proportion. Once again, we're not solving, we're just setting it up. Let's go look at number 3. A school has a ratio of 10 girls for every 6 boys. Okay, there is my comparison, girls to boys. And it says 10 girls, that's going on top, for every 6 boys. And now I keep reading. If one team of classes has 15 boys, how many girls are there? Okay, it has 15 boys, and boys is going to be my denominator, so it's going at the bottom. But I need to know how many girls. And this time I'm going to use the variable G to represent girls. All right, our last one. 6 cans of soda cost $2.50. Okay, so we are comparing cans of soda. So I'm going to just put cans to the cost. And I'm going to just put a dollar sign here. 6 cans of soda to $2.50. That's how much it cost. My next question, it says, how much will 20 cans cost? I have the number 20, and it's talking about the cans. I look over here at my little key, and I notice cans is at the top. So I'm going to put 20 at the top. And it wants to know how much it's going to cost. And I'm going to just use X and put it right here for my variable. And that's how you set up a proportion.